Okay, this section is on a sign chart. And remember what a sign chart does is it tells us where a function is positive or negative. Now we're interested in where it changes signs, the sign chart. And it can only, a function or a graph can only change signs at two places. At a root or a place where it's undefined. And these are x values that we're going to be getting here. Steps on making a sign chart. First, you want to solve functions for 0. You want to factor, get the roots in places where it's undefined. Use those values and label an x-axis with them. Test any region and use multiplicity to determine a sign change. All right, let's take a look at this example. We're looking for where this function is greater than 0. We want to write our answer in interval notation. Okay, the roots, it's already factored. The roots are 0, 2, and -3. No points no points where it's undefined. Now look, there's 4 intervals: -3 or negative infinity to -3, -3 to 0, 0 to 2, and 2 to positive infinity. 4 intervals. We're going to test a point. We randomly pick 1 because 1's an easy number to test. And here's what we get. We plug it in for each of our values in our function. We get positive for each factor. Total 3 positives multiplied together is still a positive. So we put a positive symbol where 1 would be. It's in between 0 and 2. And if you've noticed, we've also labeled our roots, whether there's a sign change or no sign change, based on multiplicity. Putting in the correct sign based on sign change or no sign change gives us this, and then we're able to write the answer in interval notation. Okay, the next problem, we have this function we want to write in interval notation where it's less than or equal to 0. So finding factors and roots. Factors are -12 and 2. We divide by a and reduce. Here we've got to put the 4 in front of the x, and we end up with our 2 factors producing the roots 3 and -1/4. Label them on a number line and test 0. 0 is an easy number to test. When we test that, we get a negative number, putting a negative on our number line in the interval where 0 lies. Multiplicity now tells us we have sign changes in both roots, so we put a positive on our number line. Our answer is the portion of the function or graph that's less than or equal to 0. There it is in interval notation. Okay, our next problem, we're looking for this rational function less than or equal to 0. Notice we have a denominator here, so we are going to have points where this thing is undefined. Remember, a fraction is undefined wherever the denominator equals 0. We've got 3 roots and 2 points where it's undefined. We label them on our number line, and then we also write underneath each value whether it's a root or whether it's a point of undefined. That's going to help us later. Let's test a value. We're testing -1. That's an easy number to test. When we plug in -1 here, now notice -1 squared is positive. A -1 and a -2, that's a negative. A -1 and a 3, that's a positive. And then when we multiply these together, we get a negative in the numerator. In the denominator, we get a negative in the first spot there, and then -1 and 5 is positive. We multiply those together, we get a negative. So a negative divided by a negative is a positive. So let's put a positive where in the interval where -1 lies. Okay, now we've also indicated the correct sign changes based on multiplicity, and now we can fill in all of the signs here. Now, we're looking for this where this function is less than or equal to 0. So here's our situation. We've got to exclude any point that makes the function undefined and include all of the roots. The roots, so 0 is in between 2 positives, but 0 has to be included because it says less than or equal to 0, so we've got to include 0.